Welcome to the walkthrough for Assignment 4 in my CS 5254 course in the summer of 2023. The objectives of this assignment are to learn how to synchronize gazes by concurrent beings via a reader's writer lock, implemented using a Java stamp lock, and a fair semaphore, implemented using your solution to Assignment 3B. Videos describing Java stamp lock appear here and here. I recommend you watch these videos to ensure you understand how to apply the Java stamp lock synchronizer. Naturally, this topic is covered in class as well. The fair semaphore and the Java stamp lock are used to enhance the Java Executor Completion Service Framework implementation of the Palantiri Simulator app from Assignment 3A. Assignment 4 applies these enhancements to the Palantiri Manager, which restricts the number of beings from Middle-earth who can concurrently gaze into a fixed number of Palantiri. The Palantiri Simulator app is packaged as a project using the latest version of Android Studio. In particular, you need to be using the Giraffe version for this, which may require you to update your Android Studio version. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4, however, you only need to be aware of the following three directories: the app source main Java edu Vandy Simulator Managers Palantiri Stamp Lock Fair Semaphore, which contains the skeletons you need to fill in as described below; app source test, which is a set of unit tests that exercise many Palantiri Simulator features and can be used to help test the functionality you implement for the assignment; and app source Android test, which is an Android Studio instrumentation test that runs your app automatically. You'll also need to integrate your enhanced solution for the completion service folder from Assignment 3A into the latest greatest completion service skeleton and use it as an implementation for the being manager for Assignment 4. And make sure to address all my comments from Assignment 3A and 3B into your Assignment 4 solution. As always, to compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. This application's minimum API is 33, so you need to select an emulator that uses an API greater than or equal to 33. If you don't already have one created, you can create it by clicking on the ABD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here tasks to provide a working solution. Do not change the overall structure of the skeleton, just fill in the to-do tasks. In particular, you need to finish implementing the following to-do tasks for this assignment in the Stamped Lock Fair Semaphore folder. You'll first need to complete the to-do tasks in various methods in the Stamped Lock Fair Semaphore Manager.java file to implement a Palantiri Manager via a fair semaphore, a stamp lock, and a hash map. You'll also need to integrate your Assignment 3B solution for either the Fair Semaphore mo.java or Fair Semaphore co.java, depending on whether you're doing the undergrad or grad version, into the to-do tasks in various methods to implement a counting semaphore using either a built-in Java monitor object if you're an undergraduate, or a Java condition object and entrant lock if you're a graduate student. Your app will be considered correct if it passes all the unit and instrumentation tests and all beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri. In other words, if there are 4 Palantiri in this simulation, then only 4 beings should ever be gazing on the stream at any given time. While the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, the app title bar labels will appear green when the simulation completes. However, if the implementation throws an exception or is not implemented correctly when the simulation completes, the red title bar labels will be displayed when the simulation is done. Graduate students, or students who are taking this class for graduate credit, must perform the following additional tasks. They need to enhance the Stamped Lock Simple Semaphore Manager.java file to use Java functional programming features such as method references, lambda expressions, and/or sequential streams in several places. Undergraduates are welcome to implement these Java functional programming enhancements, but it's not required. Skeleton code for this assignment is available in my GitHub account. Once you've set up your GitLab account, you can pull the skeleton code into your repository, read it carefully, and complete the to-do markers. The additional work required by graduate students is clearly marked. Unit tests in the app source test folder are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect your problems. However, please run these tests prior to submitting your solution, and make sure to check with me and seek help if you have any questions about why any of the tests fail. This assignment is designed to deepen your understanding of synchronizing multi-threaded programs using the Java Stamp Lock Synchronizer, which provides a powerful, albeit more complex and sometimes more efficient, reader's writer synchronizer compared with the Spinlock and reentrant lock solutions covered in previous assignments. Now that we've walked through the specification for Assignment 4, let's go ahead and take a look at the skeleton implementation. Turns out there's really only one file you have to be concerned with. though naturally you need to make sure that you've got a correct implementation of your fair semaphore implementation from assignment 3B. So please make sure you update all my comments, though you can leave those files where they were. So let's go ahead and take a look at stamp block fair semaphore manager.java. This file defines a mechanism that mediates concurrent access to a fixed number of available Palantiri. It uses your fair semaphore for assignment 3B, just a plain old hash map, and now the new piece of the puzzle is a stamped lock in order to mediate concurrent access to the Palantiri. This class implements a variant of the pooling pattern, which you can learn more about at the link here. So let's go ahead and take a look at some of the fields. One field is, of course, the fair semaphore, M available Palantiri, which is your implementation from assignment 3B. You've also got a Palantiri map, which is just a plain old hash map, very similar to earlier assignments. And then you have a new field you have to fill in here, which is pretty obvious, which is a stamp lock synchronizer that's used to protect the Palantiri state. Let's take a look at the build model constructor method. So what you'll do, as you've done before, is you'll make a new hash map, iterate through the list of Palantiri, and initialize each key in the map with true to indicate it's available. And then you'll go ahead and initialize the fair semaphore to use the fair implementation. And again, we'll see that the implementations you have to do depend on whether you're doing the grad student version or the undergrad version. Down here, you can use get Palantiri to get the list of Palantiri and then initialize each key in the Palantiri map with true. Grad students should use a Java stream to initialize the Palantiri map, whereas undergrad students can use it and implement it without using a Java stream, though you're certainly welcome to use a stream if you'd like. Down here, you'll initialize the semaphore to use the fair implementation. And once again, we split up the two implementations between undergrad and graduate versions, so make sure you do the right one. And then the final thing you'll do in build model is initialize the stamp block, which is pretty straightforward. Let's come down here now and take a look at acquire. So the purpose of acquire is to get a Palantir, and it will block until one is available. This method should never return a null Palantir. However, it can throw the interrupted exception if a shutdown is being processed while a thread is waiting for a Palantir. And this is a little different from previous assignments, and I've actually gone back and updated previous skeletons. So now all the acquire methods in all the different Palantiri manager implementations all throw interrupted exception. So you'll need to go back and refactor your assignment 3B code to make sure that the acquire method no longer throws cancellation exception, which was kind of a strange vestige left over from a previous time, and make sure it throws interrupted exception. That will actually clean the code up a bit, make it a little shorter. So let's talk about what you need to do for acquire. So you'll acquire the fair semaphore, either the monitor object one if you're an undergrad or the condition object one if you're a grad student, using the interruptibly method. And then you'll use an iterator to iterate through the hash map in a thread-safe manner to find the first key in the hash map whose value is true, which of course indicates it's available for use. You'll then go ahead and replace this key with the value false to indicate that the Palantir isn't available and return that Palantir to the client. Now, a couple things to note here. There are actually some really clever ways of doing this using Java streams, which you have to be somewhat careful because it's a little bit more subtle than what you've done in the past. And the reason for that is described in this next paragraph. The implementation should demonstrate stamped lock support for upgrading a read lock to a write lock. So, of course, after you acquire the fair semaphore, then you have to go ahead and acquire the stamped lock as a read lock. And then you'll use your iterator. And the reason you're using an iterator here, instead of something like a for loop or a for each loop or so on, is so that you can restart your search at the beginning of the hash map if you're unable to atomically upgrade the read lock to a write lock. So what you need to do here, because this code is a little tricky, please take a careful look at the stamped lock upgrade example that's described in the Java documentation for stamped lock. And then, of course, also you feel free to go back and take a look at the videos that I did where I walk through how you would implement this in the context of the examples that we looked at that time. So when you're all done, if all goes according to plan, you'll then go ahead and release the stamped lock, which could either be a read lock or a write lock, depending on different circumstances, depending on how things went. And so you'll need to make sure you use the right unlock method. And of course, as always, make sure you use the try finally blocks to ensure that the lock is always released. And if something really strange happens and you don't get a Palantir, the end of the world's at hand. So in that case, the illegal state exception should be thrown, but this should never really occur in practice. So this method is a little tricky, but the good news is if you look at the stamp block upgrade example and think carefully about what you're doing, you'll get a lot of good hints from that particular example. Let's now come down and take a look at release. Release will release the Palantir so it's available for other beings to use. What you're doing is you're giving back a Palantir, and naturally you have to do some sanity checking to make sure you're getting the right Palantir. This particular code can also throw interrupted exception, and it can also throw the illegal argument exception. So the way this is going to work is as follows. You're going to update the status of the designated Palantir inside the stamp block fair semaphore manager, in other words, inside the hash map that's part of that. So it's now available for other beings to use after it's been released. This method, of course, should be efficient and it should be robust. For example, it should handle invalid Palantir values, such as null values, or values that are not valid keys in the hash map. Hopefully the tests will catch these problems, but make sure that you go back and look carefully at some of your earlier implementations, for example, your assignment 3B implementation, to see how you should do this. And if you are confused, come to office hours and/or please take a look at the frequently made mistakes video for assignment 3B. You should also lock and unlock the stamped lock field correctly to ensure mutually exclusive access to shared mutable state in a manner that's interruptible. So that's giving you a lot of hints about what you should do. Once again, the unit test will hopefully yell at you if you try to do something besides what's described here. And then, of course, as we've been doing for the last number of implementations of the B assignments, only release the semaphore if the Palantir parameter is indeed correct. So those are really the key methods. Release, which is actually fairly straightforward. It just uses stamped lock. Acquire, which is a little tricky because we're using stamped lock with this kind of conditional upgrade model that we're trying to get you to understand from reading the example and looking at the code I walk through. And then the initialization is very much par for the course. You've seen this many times before. So that's the walkthrough for the skeleton. As you can see, there's really not a whole lot to it, but make sure that you come to office hours. Make sure you ask questions on Piazza if you run into any problems whatsoever. Now that we've walked through the specification and skeletons for assignment 4, let's go ahead and take a look at running the tests. As usual, you'll come into Android Studio and click the test button. You can do this various ways. This is just the way that's doing it from the little drop-down menu that's at the top of Android Studio. As you can see, the tests are taking a little while to compile, and now they're off to the races and running. There's a lot of tests here. I think there's roughly 200 tests. And of course, you have to make sure to integrate all your solutions from the previous assignments as well. There's a combination of stress tests and normal tests and white box tests and so on. So it takes a little while to run, but when everything is said and done, you should pass all of the tests with green check marks. If for some reason you're not passing the tests, please make sure that you raise those issues on Piazza and/or in class, and I'll be happy to help you try to identify what's going wrong. As you can see, all 202 tests passed for my version, which should be no surprise. Please make sure you do the same in your solution as well. Also, make sure that you take a screenshot showing that you passed the tests and include it so I can see what you're actually doing. That's tremendously helpful in allowing me to give you good feedback because I know where to zoom in to identify what happens to be going wrong. If you want to show kind of a snapshot of everything, you can collapse all these different results, and that will show what you're doing in one fell swoop. As you can see here, there's lots of different types of tests, but if you do that, you should be able to get most of them onto one screen.